Hi, everyone. My name is Charlie. I'm very glad to be here to support CASPA, the science fair. Today, I would like to share with you how coding might change the world first. Then I will give you a quick introduction on XCamp. We also have two XCamp students here, Katie and Regina, to share their coding projects. Professor Yang has mentioned a lot about the AI. Also, I'm working in Google X. X is the incubator of project Waymo, the self-driving car. I would like to share a video about more tech details, especially the AI to drive the car here.
Back in 2009, in our early days at Google, we started working on self-driving cars. Today, we're called Waymo, and our fully self-driving cars are on the road. They use a range of technology we've built from the ground up to understand the world around them and get you where you need to go. You're about to see how it all works and what it feels like to ride in our car. As it drives, Waymo uses LiDAR, which sends out millions of laser beams per second to build up a detailed picture of the world all 360 degrees around it. It also uses radar to detect how far away objects are and their speed. And high-resolution cameras detect visual information, like whether a traffic signal is red or green. It then combines all that data to understand the world around it. For example, in this fraction of a second, it knows exactly where it is on the road. It can also identify everything around it in full 360 degrees, and then predict what those things might do next. And it doesn't just do that for the objects you and I can see. It can do that for things up to 3 football fields away. What makes everything you can see right now possible is experience. Waymo has already self-driven millions of miles on complicated city streets, and it's constantly learning from every single mile it drives. With all that knowledge, it can plan a safe path ahead. In this instance, giving that cyclist enough room to cycle past us, and also looking out for that pedestrian on the sidewalk. And when it comes to making decisions, this is a good example of how Waymo doesn't just take into account your safety. It also makes sure that both you and the people around you feel secure and at ease. So now that you know how Waymo works, it's time to take your first ride in one of our cars. Take a look around. You're now riding in a fully self-driving car. Some things might immediately stand out. The fact that there's no one in the driver's seat, no one turning the wheel, and the screens, which show you what the car is seeing and the route it's taking. But you might also notice that the ride feels a lot like being driven in a regular car. And that's the way it should feel. All this technology, which allows Waymo to see, identify, predict, and plan, should make an extraordinary ride feel completely ordinary and create a very normal journey that simply gets you from A to B safe and sound. And while it does all that, all you have to do is sit back, relax, and enjoy the ride.
Yes, thank you for looking at the video here, explain how the self-driving car works. If you like the picture here, in the car, we have radar sensors, we have video cameras, we have GPS, laser sensors, and ultrasonic sensors. As Professor Hu and Professor Yang just mentioned, all these sensors are made by semiconductor. So this is very important, to have these sensors work. In addition, to this semiconductor, we also need a code and AI to make the car self-drive. I think you might be convinced from this example how coding play another significant role in this self-driving car. Next, I would like just show a 2-minute video about XCamp. So within XCamp, how we teach kids from very young, 5th, 6th grade, start learning coding. Let me play the video here.
Computer science and artificial intelligence are tools that will change the future. XCamp Academy is a community dedicated to inspiring and cultivating the next generation of computer science and artificial intelligence talent. XCamp Academy was founded in August 2017 in Silicon Valley by 2 Google software engineers. The name XCamp was inspired by the variable X, which represents unlimited opportunities. XCamp's curriculum is developed by Mr. Xian Youxu, a Chinese diamond-level international gold medal coach. Our staff here in the US is composed of senior software engineers from major technology companies in Silicon Valley. In addition, we have strong support from international and domestic competition winners. From beginner-level Python to classic C++ courses and competition and honors courses, XCamp's curriculum is designed for students of all different levels. We prioritize personalized education, with problem sets tailored to each student's needs and an enrollment system that encourages grade skipping. By participating in team-based competitions and facilitating frequent group study sessions, XCamp also fosters an environment of collaboration to build each student's confidence in their ability to code. As of now, more than 80 XCamp students have qualified for the USACO Silver Division and above, including 13 who are in the Platinum Division and 33 in Gold. During the Teams Code Summer Virtual Contest, XCamp's teams won 2nd prize in the Intermediate Division and 1st place in the Advanced Division. At the 2021 Harker Programming Invitational, our students won 1st and 2nd place in the Advanced Group, and the top 3 teams in the Novice Group were all from XCamp. Here at XCamp, we believe that students have unlimited potential and can change the world through coding.
To support CASPA Science Fair, XCamp will provide a free 4-hour jumpstart class on coding. The class starts on June 26th and ends on July 10th, 7 to 8 p.m. every evening. I hope this class will inspire the interest of your kids in coding. CASPA also organized the Art of Programming contest in the Science Fair next August. So hope this activity will help your child start their journey in coding. If you are interested in the coding class, please scan the code to register. I also will post the link in the Zoom chat later. Next, I would like to have 2 of our students to share their coding projects. The first one is from Kaden. Kaden, are you here?
Yeah, hi.
Okay, great. Yeah, would you please introduce yourself? Then I can play the video of your project. You can explain on that.
All right, so I'm Kaden, and I'm going to be in 8th grade this fall. I'm in the 2-1C class for XCamp, and this project, Blackjack made with Turtle, I'll be presenting today, was made 1 year ago when I was attending my first XCamp session. So, yeah. So this is the intro of the game, and you'll literally see the rules. So, yeah. The rules of Blackjack are very simple. It is a card game where objective is to get the cards to sum up as close to 21 without going over. It's a 2-pillar game between you and the dealer, and both players start off with 2 cards. Then based on some of those, you can choose to either hit or stand. Hit means to draw another card, and you can repeat this action until you have 5 cards. Stand means you stop, and the dealer repeats the same action that you did. At the end, you compare your scores. Whoever has the greatest score wins, and if you both have the same score, you tie. All right, now let's play the game. So right now my score is 10. So I'm going to try to draw more cards until I get to the 21 as close as possible. So now that I reached 19, I'm going to stand and I win because my score is bigger than the dealer's score. So if you replay, I'm going to do the same thing, except this time I'm going to go over 21 and that means I lose, which means that the dealer wins. So I got my inspiration from making this project from Airplane Entertainment Systems. Every time I go on a long flight, I play this game a lot of times. And eventually, after I play this game a lot of times, I would be very familiar with the game rules. But that's only part of the reason why I chose to make this game. This game actually incorporates a lot of things I learned in XCamp, such as the use of functions, lists, and others, making it a very suitable project to choose. It would be challenging for me to make, but I wouldn't have to learn new concepts. In the end, this project took around a week to finish, and my process for making this was split into 5 parts. First is brainstorming. I had to come up with ideas on how to make the dealer and the card system work. And I took care of those by making the game War, which is another very simple card game. Second, I designed the cards and the board. Third, I made the hit and stand button. Fourth was getting the dealer to work along with the win conditions. And finally, since I had extra time, I decided to make the intro and make the rules. The second session went relatively smooth. I had some fun designing cards and the board, but it wasn't until the third and fourth parts that I started meeting some problems. At the time, I wasn't very familiar with functions yet, so as a consequence, a lot of the implementation I did with them was off. For example, while the dealer was going, I could still hit or stand and change my score, which was a major problem. Another problem I faced was actually getting the function to terminate and stop running. Although like the function would end right after I wanted it to, after I ran another function, it would activate again, meaning some things would pop out at the time they weren't supposed to. So some other problem popped up, but eventually, after a week through sessions of debugging and some tips from XCamp, I finally finished the project. Now that I've gone through more classes with XCamp, I've learned more algorithms and ways to make the game code simpler and more efficient. Thank you for listening, and I hope you enjoyed this presentation.
Thank you, Kaden. Yeah, after you learn some coding, you have the interest in coding, you made this game. It's great. Yeah, hope you learn more in the future too. Next one, I would like to have Regina to share her projects. It's called Gobam. It's very simpler version of kind of a AlphaGo. Now we just find like 5 in a row in the game. Regina, are you here?
Yeah.
Yeah. Would you please introduce yourself and your project?
I'm Regina. I'm going into 6th grade in the fall, and I made this project at the last season, which was when I was ending 5th grade. For my CS 102 class in XCamp, I made a Gobam game that has 3 playing modes. Human vs human, human vs AI, and AI vs AI. The AI part was challenging, so the teacher showed us the AlphaGo documentary, which Dr. Yang showed a few minutes ago. I thought about several possible strategies in order to win for the AI. So then I chose the defending one, where I first choose to defend, and if there's no necessary defending, then I choose to use offense. The implementation was a bit complicated, but I made it work through careful design, workflow diagrams as you see, and several runs of debugging. This is the algorithm I used for the AI function. So you check if it's already blocked for the defense, and then you just put in your own block for offense. You exit the function. When we start, we will first try the human vs human mode, and where it asks you what the player 1 is, which is human, and the player 2 is also human. And you first input player 1's coordinates, and then it will show the board with player 1, and same with player 2. And here I will just let myself win in order to make the video faster. And when someone wins, it says game over, player 1 has won, and it shows the board. Next, we will try AI vs human. First, the AI will play, meaning 2, as AI. And human is next, which is 1. And then the AI chooses a random position on the board, and then I choose a position. And then it chooses another position since there is no need for defense, so they use offense. And then I go to block them, and they do offense again. Then they choose the defense because there are 2 in a row here. And I choose to block them over there. So now I will try to build up a diagonal, but they blocked me off. So we stopped it, and then we started again, this time playing AI vs AI, where we have 2 AI players playing against each other. Both of them first choose a random position to start the game. Here, player 1 sees there are no need for defense, so they will use offense, and player 2 will block them. And they will keep going in this sequence, choosing defense or offense. And then they just block. And over here, they are trying to build up the diagonal. But player 1 has blocked. And they will try to keep building up in different directions or blocking off the other player from winning. Player 2 chooses to defend instead of using offense. And player 2 has won, getting 5 in a row in column 4. That's what I did for my Gobam project. Thank you.
Thank you, Regina. It's a great work. You just learn, a couple classes so you can make such a complicated game. It's amazing. Yeah, I think that's all we want to share with you from XCamp. After this, we will provide a 4-hour class. I think after this class, some of you might to build games like Kaden and Regina, they just show you. Yeah, if you are interested, join us. Also join the CASPA Science Fair. Thank you.